Hey everybody, so in this video we're going to be going over an example. So we have given here a data set. We're going to go ahead and find Q1, Q3, and any outliers. And we're also going to be constructing a box plot. So here's our data set ordered from smallest to largest. And always, if you're given a data, it could be scrambled. You want to make sure it's sorted from the smallest number to the largest. So to begin with, let's find Q1. And the way you find Q1, there's a formula that tells you not Q1 exactly, but it tells you what the position is in the set. So counting all these, all right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n is equal to 11, meaning there are 11 members in this set. Q1, all right, we want to find which member in this set makes Q1. So the way we do that is 0.25 times n plus 1. N plus 1, that's 11 plus 1, and 11 plus 1 is 12 times 0.25, or 12 divided by 4. That's going to give you 3. That means not 3, but third. So the third member in this data set, which is 1, 2, 3, 49, is Q1. So that's Q1. Q3, same thing. Instead, we have 0.75 times n plus 1. Okay, and then so that's pretty much 12 times 0.75, which is the 9th data set, or I might say the 9th data point. Okay, so that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So 60 is the Q3. And if you're wondering why this Q1 has 0.25, why Q3 has 0.75, it's because remember that Q1 is just a special percentile. And it's the 25th percentile. So you could just think of Q1 as the 25th percentile, and for that reason you have 0.25. And then Q3 is the 75th percentile. And also, I didn't mention, but Q2 is also known as the median. We call it the median. We don't refer to it as Q2, but it just means Q2 making it the 50th percentile. Okay, so we got those two. And let's find the median as well, since we're going to be constructing a box plot soon. So the median, or also Q2, you find it using this formula, 0.5 times n plus 1. Same thing like these. Instead, we have a 0.5 right here. So 0.5, n is 11, so 0.5 times 12 will give you 6, making it the 6th data point. 1, 2, 3, 4, 5, 6. 6 would be 51. Alright, so now let's find if there are any outliers in this set. And to do that, first we need to find what the IQR is. Alright, the IQR is the interquartile range, and the way you find that is by just doing Q3 minus Q1. Q3 is 60, Q1 49, 60 minus 49 is 11, so the IQR is 11. Now, the last step in finding if there are any outliers is we multiply IQR by 1.5. So 1.5 times IQR, alright, so that's 11 times 1.5, should get 16.5. Now, you're going to find the range bounded, the range that includes all numbers that don't consist of outliers. So 1.5 QR, and the range is that. So let's say you have all these data sets right here. This range tells you all the numbers that are not outliers. Any data points that are outside this range are outliers. It could be to the right or to the left. So, and this range, okay, is going to be, so let's say it's going to be Q3 plus 1.5 IQR. All right, that's the upper extreme, and the lower extreme would be Q1 minus 1.5 times IQR. Okay, so what that range is, Q1 minus 1.5 IQR, so that's Q1 49 minus 16.5. And the calculator, that should give you 32.5. All right, And then the upper extreme, the upper limit would be Q3, which is 60 plus 16.5, 76.5. Oops, 76.5. All right, so these are our limits. So any number that falls outside of this category, whether it's greater than 76.5 or it's less than 32.5, is considered an outlier. Okay, so looking at our data points, do we have any number outside of this range? 2 is a number, and that's it. 63 is the greatest, and 63 falls within this range. Okay, and 2 is the only number that falls outside of this range. So 2 is the only outlier. Now let's construct the box plot. Okay, and you could just come up with a number line just for reference. So taking a look at our data, since it ranges from 2 to 63, so we could start with, I don't know, 0, and then we just go by tens. So 10, 20, 30, 40, 50, 60, and then finally 70. And we could just have these midpoints in between, indicating increments by increments of 5. So we're going to first create a box that encases Q1, median, and Q3. Q1 is at 49, if you look. Q1 is at 49. Okay, so draw a line at 49. Approximately 49 would be, you know, somewhere right here. That's Q1. All right. And then the median, we said the median, we found it to be 51. Okay, so the median, that's approximately, you know, right, a little bit to the right of the 50. And then you have Q3, which is exactly 60. So right above the 60 mark line. Okay, now we could just create a box that houses all three of these. So you could label that just for reference, Q1, Q3, and this one right here is the median. All right, and then you're going to create these whiskers, as they call them. Just a line extends to the smallest, a line extends to the largest. And remember that these lines are extending to the smallest non-outlier and the greatest non-outlier. So the smallest non-outlier, taking a look, this being sorted from least to greatest, the smallest non-outlier is 43. So we're going to extend a line that goes all the way to 43, and that's pretty much somewhere right here. Okay? 43 is somewhere right there. And then to the right, okay, the greatest non-outlier just happens to be the greatest number in this data set, 63. Okay, so looking at our number line, 65 is right here. We want 63 about approximately right here. All right, and then now we want to include the outlier, and we include the outlier as an x. So we said the only outlier is 2. Looking at the number line, you know, 2 falls somewhere around right here. And that's it. If you had multiple outliers, just keep labeling them as an x. And that's it. This is your box plot.